very warm welcome to this collaborative event between Cork Circus Factory and that's us, three, and the National Space Centre, that's here. My name is Brian O'Mahony, and these are my acrobatic associates, Haj and Jude. Show off your circus muscle there. Yeah, go on. Okay, very good. So, we have a STEAMy workshop for you today, and STEAMy presentation. That's S-T-E-A-M. Does anybody know what that stands for? STEM, you probably know STEM, but this one is STEAM. This one is science, technology, engineering, arts, and mathematics. Very good. Now, you probably might be wondering what place arts has in that little acronym there. And as did I, when I kind of started to dabble in circus myself. I'm a chartered engineer. I qualified from UCC some 12 years ago, been working in the industry ever since. And early on in my career, I found the Circus Factory, which was I found to be a great release for my 9 to 5 is very heady maths type stuff, and I wanted to find a place where I could move my body and something totally opposite. But the more you look at circus, and the more you look at engineering and maths and physics, the more you see the two come together. So my particular skill is juggling. Club juggling, particularly. That's these bowling pin apparatus here. Juggling, like a lot of circus arts, involves manipulating objects to get them to move in magical, mesmerizing, and unnatural seeming ways. But it is natural, of course. These objects have to behave in accordance with the rules of the world. And circus performers are, I'll let you in on a secret, not actually magical. And in fact, what we do have, though, is we have a secret collaborator in the laws of physics. So, obviously, there's simple things like when you throw this up, it's quite useful that it comes down again at 9.8 meters per second back to my hand, but that's to be expected. But the more interesting tricks are when we incorporate more complex or interesting laws of physics. Like we've got the center of gravity for balancing things like leverage, momentum, friction, and even centrifugal force, which is a fun one. Now these clubs, in particular, are more steamy than others because one of the wonderful things about modern circus is that you can use technology and engineering to enhance your performance. So we get to use these to do things like this. Thank you. We can get the lights up again. So that's just an example of the kind of things you can do with manipulating static objects in circus. But what I'd like to do now is focus more on a specific law of physics called angular momentum, conservation of angular momentum specifically. And I want to talk about that through the more physical circus arts. The things you can do with static objects are good, but when you're using your body as a flow prop, as in the case of acrobats, aerial performers, and dancers, that opens up a whole new dimension of being able to manipulate the laws of physics to make your body move in ways that are unexpected and interesting. So, first off, I'd like to demonstrate how the concept of the conservation of angular momentum comes into play with backflips. So Hadj, if you could stand up for me. And I'll tell you when to do the backflip now. So, to do a backflip, Hadj needs to push with his legs and swing his arms with enough force to do two things: to lift his body into the air and to apply enough torque to his body to spin himself around 360 degrees so his feet touch the ground so that he turns around before his feet touch the ground, essentially, or exactly in time to touch the ground, I suppose. So you give us a demonstration there first. You high enough there?
Yeah.
Yeah. Good. Thank you. Now, the interesting thing about that is when he leaves the ground, he has to have had applied enough torque to his body to get the whole way around. And once his feet are off the ground, he can't apply anymore. So the concept of conservation of angular momentum, I have this on this card because once when I was in school, I had cheat sheets in a science test, and the teacher told me, "You're not going to be able to have it written down in real life," and look at me now. Conservation of angular momentum is a physical property of a spinning system such that its spin remains constant unless it's acted on by an external torque. In other words, the speed of rotation is constant as long as the net torque is zero. So torque is basically the force to set something in motion. It's a product of force and distance from the center of rotation, which in this case is the center of his body. Angular momentum, the law of conservation of angular momentum states that angular momentum, L, is equal to mass. How heavy are you, Jude, or the Hadj?
I'm about 90 kilos.
90 kilos, okay. Times velocity, that's the speed at which he's spinning, times the radius of rotation, which would be about half his height, which is about maybe, well, now when you're standing up, it's half your height. We'll get to that. So it's about 0.95 there. So the thing about torque is that it's easier to spin things that are small than things that are long. These weigh about the same, actually, but it's a lot easier to spin that through many rotations than it is to spin this through, just a couple of rotations. It takes a lot more torque to do that. But the problem that Hadj faces is that he can't quite apply enough torque to do the full rotation as he is. So when his feet leave the ground, he has to change something to make that full rotation. Now, angular momentum must stay the same. That's the law of conservation of angular momentum because you can't apply more torque. His mass must also stay the same. The velocity is the thing we need to speed up. So if this goes up and the equation stays the same, this must come down. And that is what Hadj does. So Hadj, could you squat down for me there? Now, his radius of rotation has now shrank to about maybe 0.5 meters from about 0.95. And that will have a huge effect on his ability to spin. So, the next time he does a flip, I want you to look at the way he tucks his legs And notice how his body actually speeds up as soon as his legs are tucked in. So. Very good. Now, if Haj did not tuck his legs in, he would not make the whole way. He would probably land on his head and maybe get a concussion or hurt himself, which he's now going to demonstrate. Yeah. People want to show Haj. Very good. Thank you, Haj.